Dear students, आज uses of dimensional analysis ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਸਵਾਗਤ ਹੈ। ਅਸੀਂ ਪਹਿਲਾਂ dimensions, dimensional formula ਅਤੇ dimensional equations ਬਾਰੇ ਡਿਸਕਸ ਕਰ ਹੀ ਚੁੱਕੇ ਹਾਂ। Dimensional analysis ਬੜਾ ਹੀ यूजफुल टूल है। ਇਹ ਸਿਰਫ critical thinking ਹੀ ਨਹੀਂ encourage ਕਰਦਾ ਬਲਕਿ ਰੋਜ਼ਾਨਾ ਜ਼ਿੰਦਗੀ ਵਿੱਚ ਵੀ यूज ਹੁੰਦਾ ਹੈ। ਇਸ ਨੂੰ ਡਿਸਕਸ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਅੱਜ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਦੇਖ ਲੈਂਦੇ ਹਾਂ।
On completion of this topic, learners will be able to discuss the importance of determining dimensions of a physical quantity, state the principle of homogeneity of dimensions, explain with examples how to check the dimensional consistency of an equation, discuss the limitations of dimensional analysis.
ਆਮ ਤੌਰ ਤੇ ਡਾਇਮੈਂਸ਼ਨਲ ਐਨਾਲਿਸਿਸ ਫਿਜ਼ੀਕਲ ਕੁਆਂਟੀਟੀ ਦੀ ਕੰਪੋਜੀਸ਼ਨ ਬਾਰੇ ਸਮਝ ਦਿੰਦਾ ਹੈ। ਮੈਂ ਇਸ ਨੂੰ ਫ੍ਰੀਕੁਐਂਸੀ ਦੇ ਐਗਜ਼ਾਮਪਲ ਨਾਲ ਐਕਸਪਲੇਨ ਕਰਦੀ ਹਾਂ। ਇਸ ਦੀ ਐਸਆਈ ਯੂਨਿਟ ਹਰਟਜ਼ ਹੈ। ਕੀ ਤੁਹਾਨੂੰ ਬੇਸਿਕ ਕੁਆਂਟੀਟੀਜ਼ ਨਾਲ ਇਸ ਦਾ ਰਿਲੇਸ਼ਨ ਯਾਦ ਹੈ? ਫ੍ਰੀਕੁਐਂਸੀ ਦਾ ਡਾਇਮੈਂਸ਼ਨਲ ਫਾਰਮੂਲਾ ਦੱਸਦਾ ਹੈ ਕਿ ਇਹ ਟਾਈਮ ਦਾ ਇਨਵਰਸ ਹੁੰਦਾ ਹੈ ਕਿਉਂਕਿ ਇਸ ਦਾ ਡਾਇਮੈਂਸ਼ਨ -1 of time है। The dimensional equations have some important uses, such as to check the correctness of a physical equation, to derive the relation between different physical quantities involved in a physical phenomenon, and to change from one system of units to another. Let us discuss uses of dimensional analysis one by one. To check the correctness of a physical equation. Checking the correctness of a physical relation or equation is based on the principle of homogeneity of dimensions. This is based on the simple understanding of the fact that only similar quantities can be added, subtracted, and equated. Can we add 5 mangoes and 3 oranges? Definitely, we cannot add non-similar quantities. In physics also, if two quantities are to be added or subtracted, they must be of the same dimensions. It is not meaningful to compare physical quantities of different kinds. For example, mass with velocity. Thus, in any physical equation, each term must necessarily have an identical dimensional formula. This requirement of similar terms is the basic principle of dimensional analysis. This principle is known as principle of homogeneity. A complicated form of homogeneity principle is known as Buckingham Pi theorem. This theorem states that an expression of physical quantity having n variables can be expressed as an expression of n minus m dimensionless parameters, where m is the number of dimensions. It helps us to understand relation among physical quantities and nature of dependence. Let us have a look at the example of time period of simple pendulum. Other relevant parameters affecting the phenomenon of oscillation are mass of pendulum bob, length of pendulum, and acceleration due to gravity. Therefore, we have 4 variables, that is, n is equal to 4. These 4 variables are built up from 3 dimensions, which are length, mass, and time. That is, m is equal to 3. According to the Buckingham Pi theorem, these 4 variables can be reduced by the 3 dimensions to form only one independent dimensionless group. That is, n minus m is equal to 1. The respective dimensional formula for time period is t. Mass of bob is m, length of pendulum is L and acceleration due to gravity is Lt minus 2. Let us consider few combinations that aim to obtain a one-dimensionless group. Let one group may be T square into G divided by ml. This grouping indicates that we cannot form a dimensionless group incorporating with mass of the bomb. Another dimensionless group may be T square into G divided by L. This is equal to a constant. On rearranging, we get a relation for time period according to which T is equal to square root of the ratio of L and G into a constant. Thus, grouping of dimensionless parameter help us to determine the form of relation and to determine dependencies. In this case, time period is independent of mass of bob. Formation of dimensionless parameter is one of the important considerations involved in the dimensional analysis based on the Buckingham Pi theorem. However, this was just to give you an idea of Buckingham Pi theorem, and full treatment of this principle is beyond the syllabus to be covered in this course. Therefore, we use the simplified concept of homogeneity that requires only dimensionally similar quantities can be added, subtracted and equated. Principle of homogeneity ਦੇ ਅਨੁਸਾਰ mass, length ਅਤੇ time ਜਿਹੀਆਂ fundamental quantities ਦੇ dimensions ਕਿਸੇ physical relation ਦੀ ਹਰ term ਵਿੱਚ same ਰਹਿੰਦੇ ਹਨ। ਕਿਸੇ physical equation ਦੀ correctness check ਕਰਨ ਲਈ ਉਸ equation ਦੀਆਂ ਦੋਨੋਂ sides mass, length ਅਤੇ time ਦੀਆਂ fundamental units ਵਿੱਚ express ਕੀਤੀਆਂ ਜਾਂਦੀਆਂ ਹਨ। ਜੇ ਦੋਨੋਂ ਸਾਈਡਾਂ ਤੇ m, l ਅਤੇ t ਦੀਆਂ ਪਾਵਰਸ ਸੇਮ ਹੋਣ ਤੇ ਇਕੁਏਸ਼ਨ ਕਰੈਕਟ ਹੁੰਦੀ ਹੈ, ਅਦਰਵਾਈਜ਼ ਨਹੀਂ। ਇਸੇ ਤਰ੍ਹਾਂ ਪਲੱਸ ਜਾਂ ਮਾਈਨਸ ਸਾਈਨ ਵਾਲੀਆਂ ਟਰਮਸ ਦੇ ਵੀ ਸੇਮ ਡਾਇਮੈਂਸ਼ਨਸ ਹੋਣੇ ਚਾਹੀਦੇ ਹਨ। ਆਓ ਤੁਹਾਨੂੰ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਦਸੀਏ। You know that many physical quantities are expressed in terms of transcendental functions like trigonometric, exponential or logarithmic functions, etc. According to dimensional analysis, transcendental functions are dimensionless. Hence, instantaneous fallout of homogeneity principle is that we can only have dimensionless groups as the argument of these transcendental functions. For example, natural logarithm of 1 plus x is equal to x minus x square upon 2 plus x cube upon 3 and so on. If x is a dimensional quantity, then each term on right hand side have different dimensions as x is raised to different powers. This violates principle of homogeneity. In trigonometric functions, angle is the argument which is dimensionless, which also shows that no dimension is involved. In physics, we have expressions involving physical quantities having transcendental terms. In accordance with homogeneity principle, argument to such functions need to be dimensionless. For example, a wave equation is given by y equal to a into sine of kx minus omega t. Here, both terms kx and omega t should be dimensionless. This inference of the homogeneity principle can be used to determine the nature of constants or variables and their units. As in the given wave function, dimension of k should be inverse of L and dimension of omega should be inverse of t, whereas the dimension of A would be L. Let us solve some problems. we are given that potential energy is equal to kinetic energy. In this problem, we have to check the correctness of the relation. According to the problem, mgh is equal to half of mv square, where m is the mass of the body, v is the velocity, h is the height, and g is acceleration due to gravity. Here, dimensions of left hand side are equal to the product of the dimensions of m, g and h, which is equal to m1 L2 t minus 2. On the other hand, dimensions of right hand side are equal to the product of the dimensions of m and v square, which is equal to m1 L2 t minus 2. Since the dimensions of left hand side and right hand side are the same, the relation is dimensionally correct. Next problem is the van der Waals equation, given as p plus a upon v square whole multiplied by v minus b equal to RT, where p is pressure, v is volume, t is temperature, and r is the gas constant. You have to find out the units of constants a and b. Principle of homogeneity apply करते plus जब minus signs नाल connected terms दे dimensions equal होंदे हन. So, dimension of p is equal to the dimension of a upon v square, or in other words, dimension of a is equal to the product of the dimensions of p and v square. We know that pressure is equal to force per unit area. Therefore, the dimension of A is m1 L5 t minus 2. This shows that the unit of A is kilogram meter raised to the power 5 per second square. Similarly, dimension of B is equal to dimension of V, that is L cube. And unit of B is same as the unit of volume, that is meter cube. Next use of dimensional analysis is to derive the relation between various physical quantities. Dimensions ਦਾ method ਕਦੇ-ਕਦੇ physical quantities ਵਿਚਕਾਰ relation deduce ਕਰਨ ਵਾਸਤੇ ਵੀ use ਕੀਤਾ ਜਾਂਦਾ ਹੈ. ਅਜਿਹਾ ਕਰਨ ਲਈ ਸਾਨੂੰ ਦੂਜੀਆਂ quantities ਤੇ physical quantity ਦੀ dependence ਪਤਾ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ. Various physical quantities ਵਿਚਕਾਰ relation deduce ਕਰਨ ਲਈ principle of homogeneity of dimensional equation use ਹੁੰਦਾ ਹੈ. ਜੇ ਅਸੀਂ ਫਾਰਮੂਲਾ ਇਸ ਤਰ੍ਹਾਂ ਕੰਸਟਰਕਟ ਕਰੀਏ ਤੇ ਨੇਚਰ ਦੇ ਬਹੁਤ ਸਾਰੇ ਸੀਕ੍ਰੇਟਸ ਆਸਾਨੀ ਨਾਲ ਪਤਾ ਲੱਗ ਸਕਦੇ ਹਨ. ਡਾਇਮੈਂਸ਼ਨਲ ਐਨਾਲਿਸਿਸ ਦੁਆਰਾ ਫਾਰਮੂਲੇ ਦੀ ਡੈਰੀਵੇਸ਼ਨ ਸਿਰਫ ਲਿਮਿਟਡ ਸਰਕਮਸਟੈਂਸਸ ਵਿੱਚ ਹੀ ਪੋਸੀਬਲ ਹੈ. ਫਿਰ ਵੀ ਇਸ ਦੀ ਸਿਗਨੀਫੀਕੈਂਸ ਸਾਡੇ ਲਈ ਬੜੀ ਇੰਪੋਰਟੈਂਟ ਹੈ. ਮਕੈਨਿਕਸ ਅਤੇ ਫਿਜ਼ਿਕਸ ਦੀਆਂ ਹੋਰ ਬ੍ਰਾਂਚਸ ਵਿੱਚ ਇਸ ਦੀ ਬਹੁਤ ਵੱਡੀ ਕੰਟਰੀਬਿਊਸ਼ਨ ਹੈ. To derive a physical relation, first of all, we explore the possible physical quantities upon which the given physical quantity may depend. By assuming the powers of the dependent physical quantities, the relation between the given physical quantity and the quantities on which it depends is written. By making use of dimensional formulae of the involved physical quantities, we express the relation in terms of fundamental units of mass, length, and time. Then, the required relation is obtained by comparing the powers and substituting their values. Let us take an example. आओ dimensional analysis ਦੀ help ਨਾਲ विस्कस फोर्स ਲਈ स्टोक्स लॉ डिराइव करिए. हाँ, किसी फॉर्मूले ਦਾ कांस्टेंट डायमेंशनल एनालिसिस द्वारा डिटरमिन नहीं किया जा सकता. स्टोक के अनुसार विस्कस ड्रैग फोर्स F ਦੀ डिपेंडेंसी 3 फैक्टर्स उत्ते है. पहला कोएफिशिएंट ऑफ विस्कोसिटी eta, दूजा वेलोसिटी ऑफ द स्फेरिकल मास V and तीजा रेडियस ऑफ द स्फेरिकल बॉडी R. ਹੁਣ coefficient of viscosity ਦਾ dimensional formula m1 L-1 T-1 ਹੈ ਤੇ static liquid medium ਵਿੱਚ move ਕਰਦੀ ਹੋਈ ਕਿਸੇ small spherical body ਲਈ Stokes law derive ਕਰਦੇ ਹਾਂ। To derive the relation, first of all, we write the observations in mathematical form as f depends upon eta to the power a, velocity v to the power b, and upon radius of body r to the power c. Combining, we get f is proportional to eta with power a, v with power b, and r with power c. Or f is equal to k into the eta with power a, v with power b, and r with power c, where k is the dimensionless constant of proportionality. On applying the principle of homogeneity of dimensions, the dimensions on the left and right side of the equation should be the same. Hence, dimension of f is equal to the dimension of k, eta with power a, v with power b, and r with power c. Neglecting the dimension of k as it is dimensionless and putting the dimensional formulae of each quantity, we get m1L T-2 equal to m1 L-1 T-1 whole to the power a multiplied by L1 T-1 whole to the power b, further multiplied by L to the power c. Applying the law of indices and rearranging, we get m1 L1 T-2 equal to m to the power a L to the power minus a plus b plus c t to the power minus a minus b. For dimensional consistency as required by the principle, the powers of individual basic quantities should be equal. On equating the powers of m, L and t on both sides, we get a is equal to 1 minus a plus b plus c equal to 1 and minus a minus b is equal to minus 2. On solving these linear equations, we find a is equal to 1, b and c are also equal to 1. Hence, the relation becomes f equal to k into eta, v and r. It is clear that we cannot determine the constant k using dimensional analysis. But experimentally, it is found to be equal to 6 pi. Hence, Stokes' law for viscous drag could be written as f equal to 6 pi into eta, v and r. You can notice that it is not possible to evaluate constant by dimensional analysis. Further, numbers of basic quantities involved in the dimensional formula determine the numbers of equations available for simultaneous evaluation. As such, it is required that the number of variables involved should be less than or equal to the numbers of basic quantities involved in the dimensional formula. If the quantity belongs to mechanics, then number of variables should be limited to 3 at the most. If there had been 4 variables in the example of viscous force, then we would not have been able to solve simultaneous equations. Let us now see how can we convert one system of units to another. You know that same physical quantity is expressed in different units. It is clear that conversion of unit is associated with single physical quantity. Also, a physical quantity has different scales of measurement such as meter, centimeter, yard, etc. for measuring length. Whatever be the reason of different units being used, we need to have a conversion factor which converts one unit into another. For example, 1 kilogram is equal to 1000 grams. Here we would derive a process to affect the conversion of one unit of one kind into another kind. Or we derive a dimensionless constant as a conversion factor. The basic principle of process involved for conversion of unit is that a given physical quantity has same dimensional constitution whatever be the system of units. For example, whether we say 1 inch or 2.54 centimeters, the length remains the same. Now, as we have discussed earlier in our previous class, if U is the size of the unit and N is the numerical value of the physical quantity, then measure of the physical quantity is NU. If U1 and U2 are two different units of same physical quantity and N1 and N2 be the numerical values of the physical quantity in terms of the mentioned units respectively, then N1U1 is equal to N2U2. If A, B and C are the dimensions of the physical quantity in mass, length and time, then N1 into M1 to the power A, L1 to the power B and T1 to the power C is equal to N2 into M2 to the power A, L2 to the power B and T2 to the power C. This shows that N2 is equal to N1 into M1 to the power A, L1 to the power B and T1 to the power C upon M2 to the power A, L2 to the power B and T2 to the power C. This is the formula used to convert a quantity from one system of units to another. In case only one unit of the quantity in first system is involved, we can put N1 equal to 1 in the equation. May we now convert 1 joule into ergs? On substituting N1 equal to 1 and applying formula, we can convert joule into ergs. We know that the dimensional formula for energy is M1 L2 T minus 2, that is A is equal to 1, B equal to 2 and C equal to minus 2. Secondly, joule is the unit of energy in MKS system, whereas ergs is its unit in CGS system. Therefore, N2 can be calculated as M1 upon M2 to the power 1 multiplied by L1 upon L2 to the power 2, which is further multiplied by T1 upon T2 to the power minus 2. Then we convert basic units from one to another, as 1 kilogram is equal to 1000 grams, 1 meter is equal to 100 centimeters. On solving, we get N2 is equal to 10 to the power 7. That is, 1 joule is equal to 10 raised to the power 7 ergs. Now, we can say that the method of dimensional analysis provides simple and quick solutions to many physical problems. However, there are certain limitations of dimensional analysis also. The first is, the method of dimensional analysis does not enable us to determine the value of the constant of proportionality, which may be a pure number or a dimensionless ratio. The value of the constant has to be determined experimentally or by some other method. The second limitation is, this method cannot be applied in situations where there is more than one term, such as S is equal to ut plus half of at square. We cannot derive this equation as dimensional analysis will yield one of the two terms, not the both simultaneously. Such relations are called composite relations, that is, the relation which have two or more than two terms on one side of the relation and are derived in parts. Even while deriving such a relation in parts, it does not tell about the nature, such as plus or minus, of connecting various terms in the relation. The third is, this method cannot be used to derive a relation in the cases where the trigonometrical exponential functions are involved. Fourth limit of this method is that it fails to derive a relationship when a physical quantity depends on more than three physical quantities. This is due to the fact that the number of variables involved should be less than or equal to numbers of basic quantities involved in the dimensional formula. In case of mechanics, we can get at the most three equations by comparing the powers of three fundamental units, which, according to the theory of algebraic equations, can be used to find the values of three unknown quantities only. In case the physical relation depends on more than three quantities, the form of the function cannot be determined explicitly. For example, flow of a liquid of volume V depends upon viscosity eta, length of the capillary tube L, and radius r across a pressure difference P and time t. Let V be proportional to L to the power A, P to the power B, T to the power C, eta to the power D, and r to power E. On substituting the corresponding dimensions and equating the powers of M, L, and T on both sides, we get B plus D is equal to 0, A minus B minus D plus E equal to 3, minus 2B plus C minus D equal to 0. There are 5 unknowns but only 3 equations. We can only express the constants in terms of the others by solving equations, but we cannot find the values of unknowns A, B, C, D, and E. The fifth is, many physical quantities have the same dimensions, such as modulus of elasticity and pressure, momentum and impulse. While checking the correctness of a physical relation, it should be noted that the equality of dimensions of the two sides of an equation is a necessary but not a sufficient condition. The sixth limitation is, the method of dimensional analysis leads to incorrect result if the physical quantities on which the given physical quantity depends are not rightly chosen. The proper choice of physical quantities requires a sound background of the subject. I hope you are well versed with the applications of dimensional analysis. Let us now summarize today's topic. Dimensional equations have some important uses, such as dimensional equations can be used to check the correctness of a physical equation, to derive the relation between various physical quantities, to convert one system of units into another. There are certain limitations of dimensional analysis. First, method of dimensional analysis does not enable us to determine the value of the constant of proportionality, which may be a pure number or a dimensionless ratio. The value of the constant has to be determined experimentally or by some other method. Second, this method cannot be applied in case of composite relations. Third, this method cannot be used to derive a relation in the cases where the trigonometrical exponential functions are involved. Fourth, this method fails to derive a relationship when a physical quantity depends on more than 3 physical quantities. Fifth, while checking the correctness of a physical relation, the equality of dimensions of the two sides of an equation is a necessary but not a sufficient condition. So now, here are some quick questions for you to feel more confident about the topic. The first question is, give general representation of a dimensional equation. The answer is, for a physical quantity x, dimensional equation is x equal to m to the power a, l to the power b and t to the power c. The next question is, check the correctness of the relation work done W equal to mv square. The answer is, dimensionally the relation is correct, as the dimension of left hand side is equal to the dimension of right hand side. टॉपिक ते ध्यान देने ਲਈ ਤੁਹਾਡਾ ਧੰਨਵਾਦ। अगली क्लास तक बहुत सारियां शुभकामनावां।